So welcome to Intro to Best Practices in Data Management and Sharing. So all of these things, if you want to share your data, if you're into open science and thinking about the end of a project, making your data available, that involves doing a lot of that work up front when you're actually working on your project. So it's not just making that decision at the end, but thinking about implementing some practices along the way. So I'll talk a little bit about that. I'm Elisa. I'm the Research Data Management Specialist with the McGill Library. So I do have some hours that are on the Open Science Office Hours calendar, but you can also actually just see me whenever you want. So that's also fine. There's some specific hours, so that might make it easier, but you can also feel free to email me if those times don't work for you. Okay, so I'll talk a little bit about what is research data management, how does it relate to open science, why should we care about it? So talking about a little some of the mandates that we have now from funders that are sort of building in this work. There are these expectations that researchers will be doing this kind of work. What are some actual practices that you can do while you're working on a project? And then how does that set you up to make your data available at the end of a project if that's what you would like to do? So basically, research data management, I'm sure a lot of labs and groups and researchers or individual students doing research are doing a lot of this work already. So some labs, some groups might have these more embedded into their practices, and some might have them, might be introducing them, and some might not be as organized in terms of doing these kinds of practices, which is also totally fine. This sort of emerged over the last 5 to 10 years, and so there's a lot of researchers catching up with these practices. So just something to be aware about. That's totally fine. And if you're already doing everything and you feel like, wow, this is so basic, then you're super ahead of the game. So that's great. And that's probably good to know as well. So basically it's about, how you're collecting data. A lot of this refers to digital data or digitizing data that you're collecting in paper or in other kinds of means. Most data now will be generated digitally. So thinking about all these large quantities of data that you have in different formats and how to organize it, how you're going to use it, how you're going to structure it, how you're going to name those files. It's very detail oriented. Where are you putting it? Who gets access to it? How are you processing that? Do you need software? Do you need specific hardware? How do you find other information about similar topics, about other research that's related to your work? How do you join those together? And how then do you share your data or your research later when you're ready to do that, either with your own collaborators or also more broadly with the public? And that's sort of more in line with this idea of open science. All right, so why should we do it? Well, first of all, it's useful. It saves you time. It makes your practices more efficient. Thinking about in 5 years, 10 years, when you want to access the information that you've collected and you want to pinpoint a specific file, you know exactly where it is. You know how you got it, you know who collected it, you know what it contains, right? So that's sort of setting you up in advance to have that later. Also, there's now requirements that people start implementing these practices with the idea of sharing data broadly at the end of projects. So all of these policies that are coming from the funders, the aim of it, the overall aim is to enhance reproducibility of science, right? To make research reproducible so that we can verify the findings and that we can build on it, right? And do new research. And so this rolled out in a few ways. Some of the agencies are now requiring data management plans when people apply for funding, and those are the same for students as well as researchers or PIs. And they're going to roll out a requirement for data deposit when appropriate, right? So if there's no reason why you can't share your data, they will expect you to do this at some point, and that will become the norm for people who have funded research. It's going to be implemented over a few years, so it's not going to be like they're going to go back and tell someone to do this who had done their project a few years ago. It will only be going forward once they actually have the policy, but that's coming. So just, I'm not going to go too far into this, but just if you want more information, these slides will be available. And basically they said they won't start the data deposit requirement this year, but they're actually right now have a committee working on planning what that's going to look like and which streams of funding it will roll out to. And it will most likely be those kinds of fields where there is already an expectation of sharing, like genetics and things like that, where there is an expectation, there are repositories. It will be more mandated for funding coming in the next few years. But notably, it says it is not an open data policy, right? So it's not saying everyone has to do it and you have to make it publicly available. A lot of people do research with human participants where they have some information that absolutely can't be made public due to privacy concerns. So they're saying that there's a tension there, and you can have justification for not sharing the data, but where you can share it, it should be shared and it should be fair. So I'll talk a little bit more about what that means, how to make your data fair toward the end of the workshop. And just an example from last year, so they started to roll out in all clinical trials a requirement for a data governance plan, 3 pages in English, 4 in French, that outlines how your data will be stored, linked, and shared as appropriate, specifically how it will be as fair as possible. So they specifically say that they want to know how your data will be fair, which means findable, accessible, interoperable, and reusable. Again, I'll talk about that a bit more later. But the idea that they call this out, what this really means is something about the end of your project. Data aren't really fair while you're working on your project. They're fair once you publish them somewhere at the end of your project. So what they really want to hear is 3 pages about how you will be set up to be able to publish your data at the end of your study and to make it fair in these ways. And they mean specific things. So we'll talk about a little bit about what that means. Okay, so what are some ways we can actually do this in practice? The very basic level, it starts with organizing folders, organizing your data in folders in a structure that makes sense. This seems fine if you're working by yourself. You're like, I have my system, I know where things are, I have 3 levels of folders, some stuff goes here, some stuff goes there. Once you start working with a group or with a group of researchers or a team that has a lot of people, if you don't have a standardized way to do this, it can be very difficult to share data among your colleagues. And then later to put all that data together to publish it or to make it reproducible, right? So if everyone has a different system and you have to sort of learn everyone's system when you want to find something, that can make it really difficult. You can lose time. So basically the idea is you would come up with a structure that would work for everyone working on a project. This is not always easy. I've spent like 1 year working with a group that had 40 people, like trainees and PIs and everything, to find a structure that a very basic structure that could work for everyone, no matter what kind of data they were collecting. And then there were some exceptions, but now they're all implementing the same folder structure, right? So this is not something that is super simple necessarily, but once you have it in place, it should save you time going forward. And if people roll on and off a project, you can imagine that it's much easier to get people up to speed if you have a template for them. You say the data always goes here, the data in a process folder means a specific thing, and this is precisely what is here. The point of this is to get to a folder that has research outputs so that you have your paper, your code, and your data that underlie that paper in one folder. So if someone asks you, where's the data for this paper? I don't believe your findings, or I'd like to reproduce it. You know exactly where it is, you know which folder it's in, and you can reverse engineer how you got that data set to that final folder, right? So that's the idea of like using these kinds of practices. I'm including a link, which will be in the slides, to Project Here, which is sort of, it was grant funded and it brought together a lot of faculty from around North America to work on a standardized system of coming up with a folder structure that people can build off of. And on the web, these are clickable, these little links. So you could click into the data folder and it would give you a description of what's typically contained in there. For like a metadata folder or for a README folder or code books, it would explain what you would put there. So that's kind of handy because it's a little sort of template that you could take and use for most kinds of projects. And it also explains what it means by documentation and things like that. Okay, so we're gonna try this. If it doesn't work, it's fine. So you would want to try to go to slido.com with this little number thing, or you can take the QR code and you can feel free to come up and grab it. I need 3 people to respond for this to work so that I can like go to the next thing. So I'll have to wait. And if it's not syncing or if people claim they've submitted something, then we will just keep going. So we'll see how it goes. Again, haven't done this in person in a long time. Normally I can just give a link in the chat and it's super nice. No chat here. Okay, it says when someone's typing, so it seems to be synced at least. 2 people. I just need a third, now 1 person. We need to go back up to 2 or 3. 3 people. Okay. Don't worry about it too much. Don't overthink it. So basically it's saying I'm showing you a photo of a dog Chopin. How would you name this file? Imagine it's an image file. Dog-Chopin, dog, Chopin.png, Chopin_slipper, Chopin. Cool, we got a few. This is awesome. This is working so well. Dog version 2, dog with shoe. Animal, that's that could be a lot of things, huh? I'd be scared to type that, to open that file. So you can see that we're all looking at the same image and we're all have the same instructions, and there's maybe a few that are similar, but none that are exactly the same, right? These file names, which is fine, but it just means that people have different subjective interpretations of what's the most useful way to name something, right? So you can see someone put the date. Some people think it's important he has a shoe. Other people think it's black and white that's important. If you just have it called Chopin, is it the dog? Is it the composer? We don't know, right? I mean, I guess you probably would know if this was on your own computer. I had a photo on my computer called Nose Magic, and I was like, what is that? And then I opened it and it was like graffiti, and I was like, okay. But like, I could have organized that better, I think. And so the idea here is that if you're collecting a ton of files of different types, and there's multiple people doing data collection, or even if you're collecting a bunch of data and then you want to revisit your data in a few years, you want to title that file in a way that sort of tells you what's actually in it without having to open it. So that's the idea. So the best practices would be, you would include the date of the file creation. Of course, some people use software or tools that collect files automatically and name them, and then you can't really do anything about that because you have scripts related to that, and that's outside of the scope of this. That would be something you would think more about at the folder level rather than the file level. But when you have control over naming files, you want to include a date in this year, month, date format, so it's numerical. And that's an international standard. It's actually the international standard 8601. I know, now you know that. And the reason we use that is because it's machine readable across systems and different software, right? So software won't be confused. Most software, most systems won't be confused that that's a date. It'll read it as a date, even Excel, if you can believe it. So, and the other thing is that if you use like words or acronyms for months, let's say like April, Avril, if you shorten it, then if somebody doesn't speak the language that you're sending the file to, they might not know what month that means. So if you use numbers, that clears that up. It's a more universal way of communicating. So there are standards for even things like naming files that make things more efficient, that make them more machine readable, which means later they can be used in different kinds of software programs, right? So there's no block with that. You might want a project acronym if you're working on many projects, or if you're in a team, there might be multiple projects. That would be helpful. If you have multiple people collecting data, you might want to put the initials of the person who collected it. So that way later, if somebody looks at the file and they say, I don't really understand what's going on with this, they know who to ask about that. You might want a topic or like a subject of the file. So is it the dog? Is it that it's black and white? Is it that it has a shoe? Like, what is the point of that file? So have a shorthand. And then you want to keep track of versioning. So instead of redating a file, you would put the version number, version 1, version 2, version 3, version 1.1. So you would have minor versions, major versions, and you would decide what constitutes going from one to the next. So that way, if you have multiple files of data, then the latest version chronologically is the one that's the final one. That's how you know. So you don't have to worry about final. Really, this one is the final one, that kind of system. If it's the last number, that's it, so that's how you know. Okay, we're gonna try this again. Hopefully this works. So now we're gonna have more information. How would you name the photo according to the information that you have now? It's a photo of a dog Chopin. It was taken on August 5th, 2018. It's a Polaroid photo. It's black and white and was taken in Toronto, Ontario. Nobody wants to be the first one. Oh, think about. Also, it's like anonymous. Okay, so we have dog hyphen Chopin underscore Polaroid, and using the international standard for dates, everybody. So some people went with today, some people went with the creation of the photo. That would be more likely the one we would use. Oh, the airport code for Toronto. Somebody put that in. That's fancy. I like it. And you see, you see airport codes, you're like, that's a standard. We know where that is. I know exactly where that is. So we have some variations. The nice thing here is you can see we're starting to get more of a consistency, right? People are putting the date, they're putting something about the topic, the location, something about the substance. There's some initials. I see saying that it's a photo could be useful, Polaroid. Still, everyone has a different file name, right? So unless you have something to actually point to where it says, this is how you name your file, put the date first, the topic, the acronym, you're gonna have inconsistency. Everyone's gonna come up with something different, even if you're all working on the same thing and have the same, very narrow set of things that you could apply to the name of the file, right? So all of this is to say that when you're working on a project, a best practice and something that funders are now asking in data management plans, a big part of that is, what is your file naming convention? Give us an example of it. How will people know that that's how they should name files? So if you already have this up front, that's super easy to fill out in a data management plan. It's super easy to explain, and that all points to like the feasibility of a project, right? It's more feasible if it's more organized. It's more feasible that later you'll be able to share that data easily because you know exactly what's in each file because they're all named super well. You don't have files floating around called Untitled 1, Untitled 2, or something like that. You're not losing any data, you're not missing anything, right? So that's sort of the point of the file naming. You can also think about ways to name files that help you sort them or order them, right? So if you put dates first, you can sort them chronologically in most systems very easily. If it's more important about the subject or the topic, you might want to think about putting that somewhere in the file name where it helps you organize it more easily, or by type, or you can force order files if they need to be in a specific order by just putting the number up front, right? Sometimes when you work in Microsoft systems, you do have to force order things because it likes to order things. I can't remember if it's alphabetical or by, I think it's alphabetical. It's not by when things were created. So if you want it by when it was created, you would have to force order it that way. You'd have to think about that up front, right? So all of this is to say that you're trying to aim for making file names that are machine readable, but also human readable. Like we understand what it is, and a machine will read it and not be upset about the file name, right? And so if you've noticed, and a lot of you use these probably because you use systems where you can't use spaces in your file names or things like that, but you want to avoid spaces or special characters, you could use hyphens or underscore, camel case, which is where you use upper and lower case for letters to separate the parts of a file name. Never spaces, never slashes, because then some kind of program is going to get confused or angry with you. So basically also when you're thinking about a project, how do I know what my file name is? How do I know, the way we're going to order our information in folders? You would have ideally a README document that would be sort of updated as you're working on a project and something that everyone working on a project would have access to, right? And it would explain this. It would have a diagram of your folder structure. It would have the file naming convention with examples. It would have the funding source, how much funding. It would have the locations of the data. Like, if you have super sensitive data, does it have to be in a specific location? If you don't, is it in this location? Are there copies of the data? Things like that. If you use abbreviations or acronyms, you'd want a key. So that should be located somewhere. If it's all in the same document, that makes it easier. So this is a really big kind of documentation to have to sort of be doing research data management well, and to prepare your data to be shared later, because you can just take this document and share it with the data, and then anyone who wants to reuse your data has all the information they need about how to go about doing that, right? And what things mean. So I'll show you an example. So let's say you have a file naming convention, a schema that you came up with in your lab. You could go ahead and put it in a table like this. You would list all the file types you collect. So this has microscope image, but you could have even CSV files, Word documents. You could have MRI imaging, whatever images, stuff that you guys might be collecting. You'd have a long list of it. And then you would have the schema itself, which is like the parts of the file name conceptually. You have date, you have microscope, you have image number. Then you have a key for that. What do you mean by date? You mean it's in this specific format. What do you mean by microscope? It means the name of the microscope or the number of the microscope or whatever it's called. And then what do you mean by the number? So the sequential formatting of that. How would you go about putting that? How many digits? And then crucially, you have an example, right? So that anyone can look at it and say, any files I collect of this type have to be named like this in this convention, and here's an example. Right, and that's a way to point to it so that a lot of people can understand the same way to consistently name a file. And then also, if you share your data with others, or later, if you want to publish your data openly, everyone would have access to this and would be able to understand what your files are. Because if you end up looking through some repositories, we have some data sets in the McGill Dataverse, which I'll talk about as well, that have like hundreds of files, thousands of files associated with them. And a lot of repositories will not let you keep them in folders. So it's just like a flat list of pages and pages and pages of files. So if you don't have some kind of way of reverse engineering what all of those are, how to put them back into the folder scheme that they're supposed to be in, it'll be very hard to reproduce or replicate the work that, you know, that those data have contributed to, right? Or to even use them for anything else. Another example in a README document is that you could have, you know, an abbreviations key, where if you have a long list of things that you're using that you want to abbreviate in your file name, like people's initials, for example, so you'd actually have their name here so that you would know who that is. And this is really when you're thinking about projects that happen over multiple years or over 10 years or 20 years, it becomes really important to keep track of these things because people forget. And so some people might be working on a project for 1 month and collect some data, and you have to sort of have some awareness of who they were and what they did. Any questions at this point? I'm happy to sort of pause if there's questions, or I'll just keep, everyone's like, wish I had used my drink ticket. These two are the smart ones. You guys got drinks, huh? Okay. What are some ways we can make data fair? So I talked about, you know, all the data management, some data management aspects, and I also had mentioned FAIR. And that had been called out by funders in terms of like, they want people to be doing this. This is an open science best practice. This is something that actually kickstarted a lot of the open science movement, is this idea of making data fair. And we're talking about digital data in this case, and the fact that we're in an era of people collecting more and more and more data because of the fact that we can do it digitally with a lot of tools, and that we can store them. We have a lot of space for data. So it's an acronym, the FAIR framework. It stands for findable, accessible, interoperable, and reusable. And I'll go into each of these, what that means. So what is findable data? There's a few characteristics of each of the FAIR, each letter in the acronym. So I put them all here, and then I put a sort of too long didn't read, like, what does it actually mean? So basically it's saying very specific things that you would do with your data. And this is when you're at the point where you're ready to deposit it somewhere, to make it openly available, or to make it available somewhere by access control. So I'll just go back. I forgot to mention that the FAIR principles refer to data that are as open as possible, but as closed as necessary. So it doesn't mean that you have to openly share it to be doing open science. It means that there has to be some way for people to know that those data exist, and some way for them to know how to access them if there's some control way of accessing it, right? It doesn't mean they're not open. It just means they're not open to the public without, you know, signing up for something. It's not quite the same. So basically, to make it findable, it has to be somewhere so you can find it there, right? It can't be just in your computer. It has to be in a repository. It has to have some documentation, like that README file that explains what's going on with it. It also has to have metadata, so you have to have some information about it, so that if someone goes to Google and types in some keywords, it relates back to that data set somewhere. So that's metadata, data about data. And it has to have a persistent identifier. So this is really specific. It has to have a unique identifier for itself. So if you think of books, they have ISBNs, like things that have barcodes. There are a lot of systems that use unique identifiers. Data sets use it as well, right? So it has its own identification system. So basically, it's a permanent link that points to the data. So it makes it findable. It can change URLs, but the DOI will never change. It's a unique identifier. So URLs aren't unique. Anyone can, when your URL is up, someone can buy it. Someone who manages a series of URLs can deaccession them, but the DOI remains forever. Not forever, until we decide not to have them anymore. So your data set can move around the internet, but the DOI will always point to it. And notably, they're machine readable, meaning that computer systems, search algorithms can find them, right, and can understand them and connect them to the data set themselves. In terms of making it findable in a repository, so the first step is to put it somewhere. You would deposit it. That's the term we use. You're depositing it into a repository. There's a bunch of different types. There's general ones like Dryad and Figshare. There's domain-specific ones. So there's probably a neuro one, huh? There's Open Neuro, which is for that kind of stuff. Then there's also institutional repositories, meaning that McGill has its own data repository. Anyone affiliated with McGill can deposit into the McGill Dataverse. So it's an instance of a Dataverse installation in Canada, which is open source software. You might also have code or software along with your data, which can also go in any data repository, but then there's also other places that are better designed for code, such as GitHub. It's not really a repository though, so it's kind of like, if a lot of people are using it that way, maybe that's fine. But if you wanted to have a preservation or an archival version of your data set in code, you would go to a repository. And you would also be expected to sort of deposit the documentation around your data. It's not just the files of the data sets themselves, but also those README files, data management plans, any information someone might need to replicate whatever you've done or to reuse that information. So that leads into like, what is accessible data? So basically data should be in a repository, they can be found. Doesn't mean they're accessible. Some repositories are totally closed, or you need an account, or you need to be a specific type of researcher to access them. To make it accessible as possible, it should be in an open public repository. That's sort of what that means, where like anyone can go access it. And that you want metadata, so the information about the data set is both human and machine readable. So what does that mean? So human readable metadata means that you have a description of your project, right? So like an abstract, that's not really for the benefit of computers or machines, that's for the benefit of the person coming there to try to use your information. Any notes that you might have that would be necessary to replicate those findings, you could think of it like you have a text document or a Word document. And yes, technically machines can read Word documents, I know that, and they can go through it and like find things and parse that information. But the point is, you're probably not putting it there for machines to search through those documents. That's not very efficient, right? So when we're talking about machine readable, we mean things that are interoperable across systems and that have and that can be parsed more easily. So like ORCID, an ID, right? That's, if we just type someone's name into Google, there could be 1 million people with that name. There's only one, person per ORCID ID. So that makes it easier to identify specifically the person you're talking about. Licenses for data sets are machine readable. So that's another, I'll talk about that a little bit more. But generally thinking about having a mix of these to make it understandable for people, but also accessible throughout systems that might be hosting or providing the searching for your data. So what is interoperable? I think this one sounds really like confusing. And the sort of way to summarize it is that data can be analyzed or merged with similar data, or that it relies on data standards, documentation, and metadata to indicate to researchers which data sets or variables are comparable. So basically, boiling that down, it means it should be in open file formats, so not in proprietary file formats, and I'll talk a little bit more about what that means. And again, should include these machine readable standards, right? Like international standards for dates, like that kind of format. People not using their own kind of like fun way of talking about dates. I don't know what a fun way is to talk about dates, but you invented your own date system and you're using that. Like if you tried to search for that, you wouldn't find anything. Using controlled vocabularies. So if you're doing work in any kind of health science field, there are controlled vocabularies, meaning like, oh, and whenever I try to think of one off the top of my head of like a body part or something that there's a colloquial term for, and then there's like a specific, controlled vocabulary term for that's the official word for it. You want to use the sort of official term that people use, right? So some preservation or open file formats, for example, like Word, Excel, any Microsoft products. While Microsoft is likely not gonna be like, one day, no more Excel, ha ha ha. They totally could, and they that could happen for sure. No Word, they could be like, ha ha, that's not our business model anymore. Any day now. It's not likely, but it can happen. It's happened with Apple versions of Microsoft products in the past, like WordPerfect. There's a whole like fun librarian thing where people try to get WordPerfect files and try to open them and what they do for fun. So, you know, trying to think about keeping it in a like a text document, a text folder, a file rather than a Word file, or CSV or tab delimited instead of Excel, MP3 for audio, JPEG or TIFF for images. Not to say that you should always keep only these formats, but try to have an open version of it in addition to whatever proprietary one you have, and try to share the open version of it. So if you were to deposit data in a lot of repositories, for example, in our Dataverse, it converts Excel files to tab delimited spreadsheets. So it converts it to these open file formats. And if it can't, it gives you this very scary looking message of like, could not ingest this data set. And that's the machine readable thing of like, you used it to like have notes all over the place instead of as an actual table or something like that, which is fine, but it's, you know, the idea of like, it might not last long term if we don't keep them in these kinds of things. So just thinking about if you want to make your data fair, things like has a DOI, persistent identifier, it's in an open file format. And these things we're thinking about in advance and collecting them in advance. And then finally, what is reusable data? So that means that people should be able to understand if and under what conditions they can reuse your data set. It doesn't mean it has to be reusable. It doesn't mean that you have to allow everyone to reuse it. It just means that it has to be clear whether they can or can't and under what terms, right? So they should have clear terms or a license. And they should have information about its origin, about the original version, and about how many versions or the version history it's got. So that's what it means when you have data that are reusable. You have to think about the license that you want to use in advance. And I've seen some REBs asking folks who are applying for an ethics application to actually say in their consent form what license the data will be licensed under if they will be made openly available, and to explain that to participants, right? So I'm starting to see that more and more in sort of the feedback from REBs is that these kinds of things they expected upfront. So in terms of licenses, there are some that are open licenses. So if you put your data set under these terms, you would be able to say my data are open data. They're openly available under an open license. And that's CC0, so it's a Creative Commons license public domain, meaning you're not retaining any copyright at all. You're just dedicating it to the public domain. Anyone can take it and do whatever they want with it, and they don't have to say they got it from you or where they got it. So that's the most open license. I normally recommend people do CC BY, which is an open license, and it just allows anyone to do anything they want with your data, essentially, but they have to cite you. They have to cite the source of the data. Right, so if you're interested in an open license, I normally say you might as well get credit for creating it originally. Some people, just in terms of academia, that's the system we live in, that's the reward and incentive system. If you don't care, you can just go with public domain. There's some other CC licenses that are not considered open licenses. So if you had some circumstances where you didn't want your data to be used for commercial purposes, so like if you don't want people to feed it into ChatGPT, then you would have to put a non-commercial license on it, for example. Or if you don't want people to take your data and take any part of it out of context, you would want the no derivatives. So a lot of people who do qualitative interviews will use a no derivatives license because they want to commit to their participants that whatever they say in interviews won't be taken out of context and remixed and reattributed to someone who had participated in that study saying something they didn't say, right? So there are some reasons why you would pick a non-open license. A lot of it would be to protect participants' privacy, protect the integrity of participants' contribution to your study, right? So that's something to think about. Also, if you don't want, people to use specific things commercially, that's something to think about as well. On the other side, when you have them openly available and people can use them commercially, that could help new findings or new interventions in medicine, for example, if things are totally open, because in industry, some people have more resources, more money to produce things faster. And so if that's what you're interested in, the open license might be more appropriate in that case. I'm going to talk, I know we're almost out of time, so I'm going to talk a few minutes about the McGill Dataverse in case anyone is interested in sharing your data. for your thesis, or if you're working on a project that maybe this is a good fit. Of course, it's not a good fit for everyone. Not everyone will have data that needs to be shared. More and more journals are asking for a link to the data underlying paper, underlying any papers. I know that there's some that like will absolutely require it. So, you know, depending on if you want to publish your work and where you want to publish it, you might want to look into that in advance and be prepared for that. But this could be one option. So we're part of Borealis, which is the Canadian Dataverse repository. So each higher ed institution, or most of them in Canada, have a collection within a higher level Borealis Dataverse. So McGill has that as well. In general, Dataverse is an open source platform. It was developed at Harvard by the Institute of Quantitative Social Science. There's 67 installations around the world. So ours is hosted at the University of Toronto. The software is installed at the University of Toronto. And there's an active development community. It's open source, so they actually have developers on staff who have developed new tools for the Canadian version that have then now been integrated back into the Harvard Dataverse as well. It was developed with quantitative social science in mind, but actually it's not limited to any domain. The one limitation for our current version right now, our installation in Canada, is that you can only upload files that are smaller than 3 gigabytes. So that a lot of imaging data falls outside of that kind of size limit. But any other kind of data you can upload. It can have any file extension. It can be any type of file. And the Borealis version that's hosted in Canada, we have like 65 subscribing institutions. The CIPACs are joining as well, or not the CIPACs, the SAGEFs. Oh my God, sorry. Time every morning I'm looking for a cabin for Thanksgiving weekend, and I've got it on the brain. And there's none available for where I want to go. So it's the SAGEFs that have joined, not the national parks. The data are stored on HPC nodes across 5 Ontario institutions. So there's at least 3 backups of each data set across these 5 nodes. It's bilingual. You can use it in French. There's low barrier to access. You can access it through the browser and upload data through the browser. There's also an API if you want to upload stuff through an API. And it's notably indexed across Google and other kinds of data set search tools, meaning that if people go to search for a data set about your topic, they will likely find your data set if it lives in Dataverse. And that makes it fair. That makes it findable, right? So how it works is sort of, oh yeah, go ahead. You thinking about national parks too?
Yeah. Can you use it sort of as you're still working on the project? Like, say you have a lot
It's a really good question.
Like you want to share files across your lab.
It's not for active storage. So it's not for that. I would say that it's for when you're really in the process of like, I've submitted an article to a journal. You could put a draft of the data set and you can actually create an anonymous link to it so that it strips the author data from the page. It's not published. So you need that link to be able to access the draft. But peer reviewers could then look at it that way. But it's meant to be the sort of version underlying a submitted article or a publication, right? Not an in progress, no. Yeah. Sorry about that. The good news is we have SharePoint. Okay. Yeah, so the way it works is that we have different collections. So you have the McGill collection, under which there are a number of data sets. You could also have a lab collection. So that could have their own sub collection, could be like the Elisa lab, and then you could have a number of data sets, or you could have the project about this or that, and then have a number of data sets under that. So it's a little bit flexible in that way. And within a data set, we would expect you to have files, documentation, and then any code needed to clean or replicate the findings in a paper, and some descriptive metadata. So things like if it's linked to a publication, you have the citation of that publication with the data set, right? So that those both point to each other. And there was a study a couple of years ago, I think in +1, that showed that when you deposit data and you cite your paper in the data set, and you cite the data set in the paper, your citation impact goes up by like 30% or something. Like you get cited like more than a third of the time more than someone who didn't do that. This is the end of the day, on the day after a 3-day weekend. So I'm assuming that got through. All right, so thank you. Questions? We have a few minutes.